Okay, finally we have the last one. So second case study of lab exam 4. So again, read the description here. So basically, we want to see what factors contribute or predict how students do in the final exam of 25 Stat 252. So here we considered the final score as the response, and we considered a few factors such as the midterm score out of 30, the lab score out of 30, and the faculty information. So for the faculty information, we have the variable faculty has 3 levels. So 0 is other, 1 is science, 2 is arts. And we have another 2 factors. So science is a binary factor. So if it's 1, it means science. If it's 0, it means not in science. And then we have similar for arts. So as you can see, the 3 variable faculty, science, and arts are kind of similar. So basically in variable science, we combined art and other, and that's not science. Similarly, for arts, we consider science and other, and that would be not in arts. So we have randomly selected 57 students, and these are the data. And we have a term called mid-lab, which is interaction between midterm and lab exam, which is basically midterm score times the lab exam score. So 16 asks for a scatter plot between the final exam versus midterm. So for a scatter plot, let's do graph chart builder, and then scatter plot. So we just need a simple one. So simple one. So something versus something. The first one is y. So the final score versus the midterm. Okay. Then let's just do okay. And that looks like yeah. I mean, the scale is a little different because this plot is kind of like square, and what we have is not square, but the pattern is similar. Okay. Yeah. I mean, this D and E are kind of similar, but if you look at the main pattern here, and D is more similar to the one we have here. Okay, so question, the model one. So model one only has the midterm as predictor. So let's run model one first. So analyze, compare means, oh wait, sorry, not one way nova. My brain's not working. Analyze regression, linear regression. So final as midterm, as response, midterm as independence, and then this is it. Again, the routine things you can select include plots, because sometimes they would want this, so I don't want to run this again, so I'm just going to select all of these ones. So residual versus predicted, that's the residual plot, and have the PP plot for normality. Then let's just do OK. So first, the estimated equation. So estimated equation, so the coefficient table, so 1.324 plus 1.57 times midterm, that's C. So second one, percentage of variation, so that's R square, 0.398. 19 is testing for it asks for the sum of square residual under the null hypothesis versus the alternative hypothesis. So let's take a look at the ANOVA table. So none, again, change this to model 1. Okay. So again, the null hypothesis here is that beta 1 equals to 0. So no effect of midterm score. And that's the total sum of square. So total sum of square, and then the one on the alternative hypothesis is the SS residual. It's similar as the one we have in the one-way ANOVA. Okay, so this is the null hypothesis, and this is the alternative hypothesis. Okay. 20 asked for the distribution testing for the F test. So F test, degree of freedom is these two numbers, 1 and 55. Okay. 21 asked for what's the effect of additional 2 score on midterm. So additional 2 score on midterm, basically we have the difference is what? It's 2 beta 1. And beta 1 is 1.57. So that's 3.14. So these are pretty easy. Oh, sorry, I forgot to verify your output. So here the hint they give you is that the correlation is 0.63. So we have 0.63 here. So we have the right output. And now let's run model 2. So model 2 has 3 predictor. Model 2. So analyze regression, linear regression. So model 2, we have midterm, lab score, and then we have the mid-lab, which is the interaction term. And then let's do OK. And then let's change this to model 2. So model 2, the first question they ask is, what is the estimated average final exam for someone who scored 100 for both midterm and lab? So this is the prediction, right? So for prediction, we can save the predicted value, okay? So I don't think I have saved the predicted value. So I'm going to run this again. So I'm going to do the question again. So do analyze, compare, so regression, linear regression. I'm going to save the predicted value on standardized one. And then I'm going to continue and then OK. So this one asks for someone who scored 100% on midterm in the lab. So 100% means 30 score. So I'm going to find someone who did 30 in the midterm and 30 in the lab exam. So search 30, find next. So this guy have 30 in midterm but not 30 in the lab exam. That's not what I want. Oh, this one is what I want. So this guy, case 33, has full mark on both midterm and lab exam, and the predict value is 56.89. That's exactly C. 23, it asked for whether the effect of lab score depend on the individual's midterm. So this is looking for whether the effect of lab exam depend on midterm. So apparently this is looking for the interaction. So for the interaction interaction term is beta 3. So for beta 3, if you look at the coefficient table, so we have a p-value for 0.09 p-value is 0.215 and 1.254. So it's B. How did I have? Sorry. How did I select DE? Let me just make sure. This is interaction term. 0.215, 1.25. Oh, that's B. Sorry. 23 should be B. Okay. 24. 24 asks you. This is exactly the same question we see in practice final 1. Okay. So basically, look at the ANOVA table. ANOVA table is significant, so some factor must be significant. Again, we see the paradox here. No factor is significant here. Again, this is because the interaction term is highly similar to these two terms, so we have, again, a multicollinearity problem. But whenever you see ANOVA table is significant, we say some factors are significant. Okay. Okay, the last model, model 3. So model 3, let's do analyze regression, linear regression. So we're going to consider midterm, so no lab and no interaction, but instead we're going to consider the two faculty, science and art. Let's do continue. C25 asked for the prediction interval. So I'm going to save both prediction interval. This is CI, this is PI. I'm just going to save both of them. continue, and then OK. So again, first you want to verify the hint. So the hint give you is the SSR is 5848. So 5848, that's correct. Good. So 25 asks for the prediction interval for someone who scored 24 on midterm. So let's take a look at the data. Because I just saved a bunch of columns, so the interval is the LMCI, UMCI, and blah blah. So now we want to find someone who has midterm 24. So midterm, select this, search 24, find next. So and says someone in education. Education means what? Means it's either science or art. And let's verify. So this person is either science or art. And it's actually in other. Other is faculty. So this is the guy we're looking for. So 16 highlighted. And we have, so the LICI and UICI are individual. That's the prediction interval. So 21 to 65. Okay, that's A. And B, 26 asks you, after counting for midterm score, whether students perform better on the final. So we're considering whether others compare better than this Faculty of Science. So we're comparing science versus non-science. Okay, so the null hypothesis that is beta 2 equals to 0, and the alternative is that the beta 2 is smaller than 0. If it's smaller than 0, it means science faculty perform worse. Okay, so let's look at the coefficient table of the size. So the coefficient table for the p-value, the two-sided p-value is 0.183, and we're doing a one-sided because we're going to care the negative side. So divided by 2, so 0.909. Okay, that's 26. 27 asks for, in order to verify equivariance. So equivariance, we use the residual plot. So I think I have saved the residual plot, which is here, which is D. Okay, easy. Okay, so finally, the last section is the extra sum of square section. In this case, we have three models, so you have to pick the two right models to compare. So here it wants you to consider the two models from the three. Okay, so which two models we should pick? Here, 28, it says, do lab exam score have any effect on average final after counting for midterm? So basically, accounting for midterm, and we're testing whether lab score. So basically, the full model should consider both the testing variable and the accounting for variable. So the full model should consider midterm score and lab exam. Midterm score and lab exam, that's model 2. And the reduced model is reduce what? Reduce the variable you want to test. So we're going to reduce the lab exam, which only includes midterm. So that's the model 1, because model 1 only considered the midterm as a predictor. Okay, so now we have these two models. So model 1 and model 3. Okay, rename this. I think this is model 2. The last one is model 3. Okay, so for model 2 is a full model. Model 2, ANOVA table, I have 4, 5, 4, 7. Okay, and then for the reduced model, that's model 1. Model 1 ANOVA, I have 6, 0, 80, and the difference is 1, 5 something. And the test statistics, again, use the formula. I'm not going to talk about it anymore. And then the last one, it asks you whether faculty type has any effect on the final exam. So in this case, the full model is model 3 because model 3 considers both midterm score and the faculty information. And the reduced model is model 1 because it only considers the midterm score. Okay, and then again, just read the SSR from these two models, and that's A. Okay, and that's everything. I made a few mistakes here. I will change the file accordingly, but I am not going to make another video, so sorry. And yeah, basically practice these questions and understand why we're doing this. not just kind of like remember the procedures. If you master these questions, the final should be pretty easy. Okay, good luck.